Hello my dear students and my physics friends. The last video clip what I delivered was just an introduction. You should not think that you will get many things in a particular video clip what I am sending nowadays. These are for your understanding of my way of delivery of the lectures, and you have to be acquainted and familiar with my dialect and my way of expression, a way of expressing the things. Therefore, I have given a couple of videos, and this video also I am going to deliver to you. So viewing all these three, you can access and assess my way of teaching and delivering the things. And of course, you should also give some feedback whether you are able to understand the things or not. So when I will start my regular crash course video, there things will be more detailed and everybody can understand. Even though sometimes I speak in Hindi and a little bit over here, but mostly the deliver method of the subject must be in English. Therefore, it's my suggestion to all of you to speak good English, and the classes should be held in English. And I have seen many of my students and colleagues that they passed from my IITs and other good organizations, institutions, but they are handicapped in English. But the South Indian guys, even though they are not from IITs, they pass from simple colleges, and because of their spoken English, they are very successfully doing well in foreign countries. So you would have understood what I mean to say. My dear students, last video clip I have talked about, in brief of course, the introduction of equilibrium. In this happened our video clip as a demo lecture. You have to understand what exactly the equilibrium is. Equilibrium is a great concept in physics, and there are some misconceptions regarding equilibrium. One of the misconceptions is that students get confused between the types of equilibrium: stable equilibrium, unstable equilibrium, neutral equilibrium. We have static equilibrium, dynamic equilibrium. So they get confused. These 5 types of equilibrium in this model lecture, I will try my best to present it in best possible way so that everybody can understand. Equilibrium, what I told in the last class, that for equilibrium, a body to be in equilibrium, what is the basic condition? Its acceleration must be 0. We can see the acceleration of an object. When this object falls freely, we can see that it is speeding up, down, it is slowing down, up. That we can see in our naked eye. We cannot see the forces. Nobody can see the forces. Forces are just the means of interaction. Forces are the means of interaction. Nobody can see forces. What we observe is the accelerations, the effect of the forces. When we apply a force, the body must accelerate when the net force is not equal to 0. So the idea comes from Newton's second law, which states that Newton's second law states that when you take an object and push it with a force F, for the sake of simplicity, let's take a single force, or you can assume that this force is a resultant of all forces acting on the object. This force will produce an effect. The force is the cause. You cannot see the force, but you can see the body either speeding up or slowing down, or it can change its velocity. That's very interesting, of course. The body moves with an acceleration. If you apply a force from outside, of course, there is no inside for this single particle. For the single particle, everything is from outside. When I will talk about the system of particles, there I will tell you the internal forces and external forces. Suppose you sit inside a trolley car. This is a trolley car. And you push it from within. You push the trolley car by force F from within. Do you think that the trolley car will move? No. The trolley car will not move. I mean, the acceleration of the trolley car will be 0. The trolley car will not move because this is the internal force. This is the internal force because this is a system. This is the car. Which car? Trolley car plus this boy. This is a system. In center of mass, I will tell you that there is a system of objects or system of particles. And this force you are applying from within. This is the inside of the system. I will take another guy. This is boy number 1, this is boy number 2. This boy number 1 is applying a force from within. This is an internal force. This boy number 2 can also push the trolley car, and this boy number 2 is standing outside. Therefore, this force F dash, this is an external force. So F dash is an external force, and F is an internal force. If you take a single object, everything is external. So, why I have taken this example? I have given this example to explain what is F in Newton's second law. We are talking about Newton's second law. Newton's second law states that when you apply a force, either a single force, a lot of forces, if a lot of forces are applied on an object, the net force is the F. So on left hand side of Newton's law, this is the left hand side of Newton's law. we have this force. What is this force? This force is the net force. It is the net or unbalanced or resultant net force, unbalanced force, or resultant force, or addition of vector addition of all forces. All terms, they have same meaning. So this is the net force. Left hand side में जो force, जो symbol है, that is the force. This is, needless to mention, this is the net force acting on an object. And that is equal to mass times, this is the mass. So this is the mass of the object times the acceleration. This is a vector equation. So is the acceleration. Is the acceleration. This is the acceleration of the object. This is a very cute formula. Very cute formula. Everybody knows this formula. When you enter into the dynamics without this formula, nobody can do that. This forms the basis of dynamics. This is the basics of dynamics, basic formula of dynamics. What is that formula? Whenever a net force acts on an object or a single force acts on an object, the object will move with an acceleration. Who produces the acceleration? This force produces acceleration. So ये जो force है, इसको हम क्या बोलेंगे? Cause. So what is the cause? This is the net or unbalanced or resultant force. So this is the cause. This is the cause of acceleration. This is the cause. And acceleration, we can see in our naked eye that the body is accelerating. So this is the effect. What is the effect? Acceleration is the effect. What is the cause? The net force is the cause. So Newton's second law is nothing but the cause and effect principle. Cause and effect principle. So physics में अगर हम cause बोलेंगे तो that is the force. So if you are asked to interpret anything physically, physical explanation or physical interpretation of anything is nothing but explanation of a particular phenomena by using the idea of force. ये मन में सवाल आता है, ये फोर्स है क्या चीज? अगर हम ये देख नहीं पा रहे हैं तो फोर्स है क्या चीज? Force is that which can produce an acceleration. तो सर ये है क्या फोर्स का absolute definition, the final definition? A bob hangs from a ceiling by a thread, but the bob does not move. When it doesn't move, how can we apply this formula? You may think in that way. Let us take that example. This bob is hanging. This bob or stone, any object is hanging. When it is hanging, you can see that it is not falling, means its velocity is zero, that you can observe. It doesn't require any proof, as I told you in last class. Whatever you are observing, that you are writing. So what is the observation? This is the observation. This is the observation. When velocity is zero, its velocity does not change because it's not moving at all. Therefore, कहाँ से स्टार्ट करेंगे? हम ये देखना, we can see the effect. हम इफेक्ट को देख रहे हैं. क्या इफेक्ट देख रहे हैं? भाई ये मूव नहीं कर रहा है. अगर ये मूव नहीं कर रहा है तो इसका वेलोसिटी जीरो. अगर वेलोसिटी जीरो हो गया तो एक्सेलरेशन कितना होगा? जीरो होगा. ये एक्सेलरेशन को हम यहां पुट करेंगे. एक्सेलरेशन जीरो होगा तो नेट फोर्स क्या होगा? जीरो होगा. नेट फोर्स विल बी जीरो सिंस इट्स एक्सेलरेशन is equal to zero. The net force acting on the object must be zero. यहां से स्टार्टिंग यहां से होगा, जहां ऑब्जर्वेशन से स्टार्टिंग होता है. Since acceleration is equal to zero, acceleration zero क्यों है? Because velocity is zero. वेलोसिटी जीरो क्यों है? हम देख रहे हैं ना, इट्स नॉट मूविंग एट ऑल, इट इज हैंगिंग. दिया गया, कहां से कैच करना पड़ेगा? ये हैंग कर रहा है, इट इज हैंगिंग. इट इज गिवन दैट द बॉब इज हैंगिंग. यहां से कैच करना पड़ेगा. हैंगिंग मतलब क्या है? इट्स नॉट मूविंग. व्हेन इट्स नॉट मूविंग, वेलोसिटी जीरो. वेलोसिटी जीरो भी, एंड when velocity becomes zero, its derivative means it doesn't change. Therefore, dv by dt is zero. But dv by dt is nothing but acceleration. Therefore, acceleration becomes zero. Acceleration zero हो गया, इसका मतलब ये है net force. Since acceleration becomes zero, the net force, हम ये net लिख रहे हैं for the sake of your understanding, but this is the net force. Net force, और हम यह लिख देते हैं नेट फोर्स. न्यूटन्स लॉ में जो फोर्स लिखा गया लेफ्ट हैंड साइड में, वो नेट फोर्स है. दैट मस्ट बी इक्वल टू जीरो. सो लेफ्ट हैंड साइड में जो फोर्स है, दैट इज द कॉज, एंड राइट हैंड साइड में दिस इज द एक्सेलरेशन. मास टाइम्स एक्सेलरेशन इज इक्वल टू द फोर्स. अच्छा, और एक पेटी क्वेश्चन मैं पूछूंगा, वेरी इंटरेस्टिंग. एक एग्जाम्पल के जरिए मैं उसको प्रेजेंट करूंगा. ये एक छोटा सा मैं एग्जाम्पल लिया, मैं और एक एग्जाम्पल लूंगा. एग्जाम्पल है, यही एग्जाम्पल है. इट्स मास इज एम. क्वेश्चन मैं पूछ रहा हूं, दे net force acting on the body is a F B M A C A plus M A D F minus. मैं एक्सप्लेन करने के बाद ये क्वेश्चन पूछ रहा हूं, इसीलिए तुमको इजी लग रहा होगा. And before explanation, had I asked this question, many students would have baffled. Even I have seen many teachers. एक मिसकंसेप्शन है. कुछ स्टूडेंट्स बिकॉज ऑफ द reference of some false website or some fake sources, they got mistaken regarding the pseudo force. Without understanding the idea of the pseudo force, they are very fond of writing, sir, ये तो ए में जा रहा है ना, इसमें आ जाएगा माइनस एम ए, ये सीडो फोर्स है। ये हो गया सीडो फोर्स, ये हो गया सर फोर्स। तो ये एक बाहर से फोर्स अप्लाई कर रहे हैं, ये एक सीडो फोर्स है, ये दोनों को हम मिला देंगे तो ये आ जाएगा सर, यही नेट फोर्स है। तो ये एक मिसकंसेप्शन है, ये रॉन्ग, मिसकंसेप्शन नंबर 1। और एक टाइप का मिसकंसेप्शन है, some may think that अरे एफ एक फोर्स है, एम ए भी तो फोर्स है, एफ इज इक्वल टू एम ए, तो ये भी लग रहा है एम ए लग रहा है इस तरफ, एम ए लग रहा है इस तरफ, एंड फोर्स लग रहा है इस तरफ, ये दोनों ऐड हो जाएंगे। ऐड हो जाने के बाद हमको मिलेगा एफ प्लस एम ए। ये और एक मिसकंसेप्शन है, दिस इज रॉन्ग। दो मिसकंसेप्शंस बताया। आई टॉक्ड अबाउट 2 मिसकंसेप्शंस। एक है क्या, सीडो फोर्स लगा देंगे एम ए, ये एफ लग रहा है, एफ प्लस एम ए, द नेट फोर्स। मैं क्या पूछा क्वेश्चन में, ये नेट फोर्स क्या है, ये ऑब्जेक्ट, सिंपल, द सिंपलेस्ट क्वेश्चन, यू कैन नॉट आस्क एनी क्वेश्चन सिमिलर देन दिस, दिस द सिंपलेस्ट क्वेश्चन, बेसिक क्वेश्चन। द नेट फोर्स एक्टिंग ऑन द बॉडी इज, सर ये दोनों तो नहीं होगा, एम ए होगा, एम ए। एंड मोस्ट students, they go for, some of the students, many students, they go for almost all MA, because sir MA भी तो force होता है, MA भी force होता है, because F equal to MA. So you have to understand exactly the meaning of this formula. I have been trying since a long time to explain what exactly this formula means. F क्या है, F है force, this is the force. This is the force. Which force? Net force. This is the net force. But MA क्या है? MA force नहीं, हम जो पढ़ते हैं इसको F is equal to MA, is equal to is not that. F is equal to MA. MA into a product of mass and acceleration है ये इसके साथ समान है, इसके साथ equalize है. It is equal to F. Of course, you would have understood that yes, it's proportional to the MA, and the constant proportionality, let it be K. And in physics, we have the standard principle of taking the proportionality constant 1 in this way. So F is equal to MA. In that also you can argue F MA के साथ equal बनाया गया. But MA जो होता है product of mass and acceleration, it is not the force. It is not the force. MA force नहीं होता है, नहीं होता है, नहीं होता है, 3 बार मैं बोल रहा हूँ. You have to remember it. It is so, MA force नहीं है. तो force क्या है? भाई जो लेफ्ट हैंड साइड में है वही force है. तो सर और थोड़ा एक एग्जांपल देके हमको थोड़ा सा समझाइए एक्चुअली F होता क्या है. So it goes without saying that F is equal to MA in this great formula. The force F is the net force acting on the object. This force can be any force. सर any force बोल रहे हैं, ये pseudo force हो सकता है. हाँ, ये pseudo force भी हो सकता है. Pseudo force क्या है मैं बताऊंगा. So it can be any real force, it can be any pseudo force. So real force क्या होता है, pseudo force क्या होता है? रियल किसको कहते हैं, सीडो किसको कहते हैं? रियल का ये मतलब ये है, अगर हम ये बॉडी को छोड़ देते हैं तो ग्रेविटी पुल्स इट, हम देख रहे हैं ग्रेविटी इंटरैक्ट्स, बिकॉज ऑफ द ग्रेविटेशनल इंटरैक्शन बिटवीन द अर्थ एंड दिस ऑब्जेक्ट, द ऑब्जेक्ट accelerates down. Planets are always accelerating towards the sun. Satellites are always accelerating towards the planet, being pulled by gravitational force. So, when we talk about the force F, this is the net force. So, this net force may be a single force, It may be a combination of forces. This force, net force, can be a combination of real force or real forces and pseudo force or pseudo forces. Real force क्या है? What I am explaining, real force is that force which arises out of interaction between the objects. तो सर कुछ एग्जाम्पल दीजिए. बर्निंग एग्जाम्पल दिया ना. The earth pulls it because of or via gravitational attraction. Two magnets, North Pole and North Pole, or South Pole and South Pole. If you release, they will repel. This is magnetic interaction. North Pole and South Pole, they will attract. Magnetic attraction, magnetic repulsion, like poles. Unlike poles, magnetic attraction. Like charges, electric attraction. Unlike charges, electrostatic repulsion. So these are all the interaction, the real forces. So electric force is a real force. Magnetic force is a real force. Gravitational force is a real force. Spring can pull, a compressed spring can pull, an elongated spring can pull, and compressed spring can push. The spring can push, spring can pull. The spring force is a real force. Pseudo force is not a real force because pseudo force comes because of or due to the kinematics, a relative motion between the observer and the object. I will be talking about it in some of my videos. I will be preparing for you for the regular crash course. Well, so we are trying to understand the meaning of F is equal to ma. That is Newton's second law. So F is the force. It can be gravitational force, it can be magnetic force, it can be spring force, it can be tension, it can be normal contact force, it may be frictional force, it can be buoyant force, it can be viscous force, it can be any type of forces. It can be a pseudo force, or it can be the combination of all types of forces. Well, but it is the net force, unbalanced force, acting from outside for an object, and that is equal to mass of the object times the acceleration. So ma is just the product of mass and acceleration, it is not the force. So the net force acting on the object or the body is, this is the answer. So answer is A. Anything can be a question in physics. So you need to understand the things from the basics. In this example I had given you to explain the concept of internal and external forces. So this gives you an idea of external force, the force acting from outside of the system, and the internal force, the force acting from inside the system, inside of the system, or from inside. Yeah. So this force, ये जो force है, ये है external force and net force. So this force must be external, and this force must be net force. So हम इसको कहेंगे net external force. F जो है न्यूटन सेकेंड लॉ में, ये net external force, ये mass into acceleration. This is the cause, this is the effect. Now coming to the example I had given you. This body is hanging है तो वेलोसिटी 0 हो गया, वेलोसिटी 0 है तो एक्सेलरेशन 0 हो गया, एक्सेलरेशन 0 तो नेट फोर्स 0 है. So net force, how many types of forces are acting on this object? स्ट्रिंग जो है, स्ट्रिंग ये ऑब्जेक्ट को ऊपर की तरह पुल कर रहा है, इट इज पुलिंग द ऑब्जेक्ट अप. by a force, that is what we call tension. And gravity pulls the body down with a force mg or mg vector. This is the gravitational force, and this is the tension force. So what is the net force? So net force 0. No, wrong answer. Net force is T plus mg, T vector plus mg vector. This is the net force. Net force is equal to 0 because acceleration is equal to 0. So what is the net force? Net force is, basic things I am explaining now. The net force is F is equal to T vector plus mg vector. T is up, so T is j cap. This y axis j cap minus y axis minus j cap. Upward plus j cap. Downward minus j cap. Rightward plus I cap. Left minus I cap. Towards you, outward plus k cap. Inward minus k cap. The basics. Well, so writing it in the terms of unit factors, ये है magnitude, ये direction. Magnitude is T and direction is up for tension. And for gravity, magnitude is कितना? mg. Direction is down minus j cap. So ये आ गया minus mg j cap. mg वेक्टर को मैं इस हिसाब से लिख सकता हूँ. T वेक्टर को मैं इस हिसाब से लिख सकता हूँ. So T minus mg j cap. This is the net force. ये net force है. But 0, net force is equal to 0 because acceleration is 0. मैं ये क्यों बता रहा हूँ? भाई acceleration 0 हो गया. This is the condition for equilibrium. Which type of equilibrium? That is different matter. I will explain that. So how to decide whether the body is in equilibrium or not? Since its acceleration is 0, it is in equilibrium in this way. So this is a bright, very suitable or easiest example for the equilibrium. सर ये किस टाइप का equilibrium है? फिर मैं इसको बताऊंगा. Now we can see one interesting thing here. I have categorized the equilibrium into 3 basic divisions: stable equilibrium, unstable equilibrium, neutral equilibrium, and 3 examples. This is example number 1. This is the example number 2. For stable equilibrium, 1 example. For unstable, this is the example. For neutral, this is the example. This is a massless rod. This is the bob, or the body of mass m. Very small. Body of mass m. Body of mass m. This is the original position. So what is the acceleration? This is at rest, this is at rest, this is at rest. Rest हो गया तो velocity 0. Velocity 0 हो गया तो acceleration 0. So this is the necessary condition for equilibrium. Acceleration 0 हो गया तो this body is in equilibrium. Acceleration 0 हो गया तो net force 0 होगा ही. And based upon their nature, I have divided the equilibrium into 3 basic divisions: stable, unstable and neutral. इसको stable क्यों कहा गया? आप इसको थोड़ा सा राइट हैंड साइड थोड़ा सा हिलाएंगे और लेफ्ट हैंड साइड थोड़ा हिला हिला के छोड़ देंगे, तो इट विल कम बैक टू इट्स ओरिजिनल पोजीशन. सो इट ट्राइज टू बी स्टेबल हियर, इसलिए इसको स्टेबल इक्विलिब्रियम कहा गया. एंड ये दिस इज आल्सो सेम रॉड बॉब सिस्टम, और पेंडुलम भी बोल सकते हैं, सिंपल पेंडुलम. इसको हम छोड़ देंगे और थोड़ा सा हिला देंगे राइट की तरफ और लेफ्ट की तरफ, तो ये क्या गिर जाएगा. तो ये अनस्टेबल है, इसको इसलिए अनस्टेबल इक्विलिब्रियम कहा गया. एंड दिस इज द बॉल और बॉब kept on a smooth surface. This is displaced either towards right or towards left and leave. It won't come back to its original position. It will remain as it is. When it is displaced from this position to this position, it will remain as it is. It will remain here always. When we displace it from this position to this position, it will remain. It won't come back to its original position, and it won't move from this position. ये ऐसा ही, इसको हम यहाँ डिस्प्लेस कर दिया तो इस तरफ डिस्प्लेस किया तो इसी को हम रख देंगे तो ऐसा ही रहेगा, वो ना इधर जाएगा ना उधर जाएगा. It won't move at all. And when you displace the object here and keep it like this, it will remain as it is. तो पूरा न्यूट्रल, इसको क्या कहें, न्यूट्रल है ये. वेलोसिटी 0, एक्सेलरेशन तो 0 होगा, acceleration तो 0 होगा, acceleration must be 0. Acceleration 0, velocity 0, therefore acceleration 0, therefore it is in equilibrium. But ये different equilibrium, ये stable, it is unstable, it is neutral. तो इसको एनर्जी पॉइंट ऑफ व्यू हम कैसे डिफाइन करेंगे? When I move it, it will move in a circular path. It will move in a circular path. It moves straight. कैसे हम देख सकते हैं? हम it doesn't require any proof. इसमें हम देखेंगे फर्स्ट केस में एक रेफरेंस लाइन ले लेते हैं. You can choose the line here or here or here anywhere. I have chosen the line here. यहाँ से खड़ा हो जाओ and measure करो distance, vertical distance. ये है h. ये if this body comes to this position, इसका h1 हो जाएगा. So h1 is greater than h. So for all positions of the bob, here the height will be minimum. The height will be minimum. अगर height minimum हो गया तो the potential energy, which potential energy? Gravitational potential energy, mgh, ये हो गया तुम्हारा minimum. ये एक rough and tough way of explaining the thing. पोटेंशियल एनर्जी यहाँ मिनिमम हो गया. बट ये केस में if you take this position of the object, इसमें हाइट h यहाँ तक, इसमें हाइट h dash is less than h. So this is the highest point, this is the lowest point. So h1 is greater than h. So this is the lowest point, this is the highest point. Highest point हो गया तो पोटेंशियल एनर्जी जो होगा that is mgh, ये हो गया maximum. So stable equilibrium में the potential energy of the object will be minimum, but for the unstable the potential energy must be maximum. But coming to the neutral equilibrium, the initial position potential as the height is h, and if you displace it towards right, the height will be h. When you displace towards left, height will be h. So the height does not change, therefore potential energy is equal to mgh, remains constant. So neutral equilibrium potential energy constant, unstable equilibrium potential energy maximum, and stable equilibrium the potential energy is minimum. Apart from these three types of equilibrium, or apart from describing the equilibrium in three different ways under the action of the conservative forces, when the non-conservative forces are applied on an object, how to define the equilibrium? For instance, you place the object here. It is at rest on an inclined plane because of the friction, because of the friction, normal reaction, all these things will be taught in detail. Normal reaction, because this slant or the inclined plane is pushing the body normal to its surface, that is called normal reaction. And of course, another reaction force is offered by the slant or the inclined plane on this block. In which direction? In upward direction. This is the frictional force. So frictional force and normal reaction, these two forces are the contact forces. This tangential contact force, normal contact force. And another force is the gravity of the earth, mg. So for the net force, because velocity is zero, because it is stationary, because velocity is zero, acceleration must be zero. तो इसको कहेंगे हम equilibrium. But it doesn't come under any category because the frictional force in general is a non-conservative force. So these divisions are not valid for the subject because non-conservative force also is applied here. But since its acceleration is zero, this is the basics or the basis of equilibrium. It is in equilibrium. Which type of equilibrium? Since it is at rest, this is called static. Rest मतलब static. इसको कहेंगे static. Equilibrium. Static equilibrium. And when the object moves under the action of conservative and non-conservative forces. For instance, when this friction is exactly equal to mg sin theta, when you push the object down, when it moves with uniform velocity, or any surface when you drag the object with uniform velocity, मतलब its magnitude भी constant होना चाहिए, direction भी constant होना चाहिए, then only you can say that this body is moving with uniform velocity. So uniform circular motion में velocity uniform नहीं होता because velocity changes its direction. When the body moves with uniform velocity, its acceleration will be zero. Its acceleration can also be zero. So acceleration zero होने के लिए velocity, either the velocity will be zero or velocity is a constant quantity. सर acceleration zero होने के लिए और क्या हो सकता है? ये दोनों में acceleration zero हो सकता है. Velocity अगर maximum होगा तो acceleration भी zero हो सकता है. And velocity minimum मतलब zero हो सकता है तो acceleration zero हो सकता है. So in this way, there are many ways. Velocity maximum. Velocity becomes maximum when the body swings. Its velocity will be maximum, but speed will be maximum at the lowest position. So in that way also we can have tangential acceleration will be zero. That is another interesting thing. And in my regular video lecture for your crash course, I will be talking about all these things in detail, bit deep into the subject matter, including all these things again in different way. Well, so अगर velocity constant हो गया तो भी acceleration हम zero लिख सकते हैं. ये केस में since it is moving, it is in dynamic condition. Dynamism or dynamic means movement. Since it is moving, we can call it which equilibrium? Dynamic equilibrium. It's called dynamic equilibrium. So in addition to the stable, unstable and neutral Equilibriums. These three types of equilibriums are only valid for an object being influenced by, being acted by the conservative forces. When non-conservative forces are applied on an object, when the body is at rest, this is static equilibrium. When the body moves with a constant velocity, that is dynamic equilibrium. So more detail we'll be talking about in our regular video classes for your crash course. So I have delivered 3 sample videos for you. Just you go through all these videos and see whether you are able to understand or not. I hope even though it's very difficult to satisfy all types of students by only 3 videos, but of course you are very intelligent guys nowadays, and you can understand the things, the way of my presentation, and many things you can access. And I hope that these things will be helpful for you to prove whether you will be benefited with our teaching or not. So when I will receive your positive responses or any types of responses, I will try to modify the things the way you like. I will be trying my best to do the things in that way. So I am really very grateful to have the opportunity being requested by the Oriya educationists to prepare some content for you. If you think that you will be benefited, definitely will go forward to prepare your most desirable video lectures for your crash course via Spark Institute, Spark classes. And of course you can refer my YouTube channel Tech Physics. There I have in detail I talked about the vector, because vector is the backbone of physics. Everybody can understand. That is purely in English. From the grassroots level, from the basics, I tried my best to lift the concept. All the concepts are discussed in detail. Sky is the limit. If I had left anything, don't hesitate to comment, because you are the people. You are the guys. Whatever we are today is due to our past students, previous students, gifted students, and you are the people who can make us successful, and we will fail to attain the success. Also, you are 50% morally responsible. I hope you understood what I mean to say. So try to scrutinize my video lectures as critical as possible, and you please deliver your critical suggestions. Accordingly, I will prepare the forthcoming video lectures in best possible way. Thanks all of you to watch my video lectures.